And before you leave today, if you can take a couple of minutes for the course evaluation, that can be found all the way to the bottom right there. All right, with that, it looks like we're all set to begin again. At this point, I'm going to pass it back over to your instructor. Sandra, you're all set. You can take it away.
Thank you very much, Pat. Hello, everybody, and welcome to day 4 of the RHCSA crash course. So today we are going to talk about time management, about scheduling jobs, and also about the big topic of the day. And the big topic of the day is containers. There will also be a mini sample exam that allows you to practice a little bit what's going on in the exam. It looks as if my camera is still not working. Let me do a quick fix. Let me read what GC is saying. Auto FS at the home folder, all was good, but the owner of the new user was not the owner of the home folder. So I manually changed ownership and all was solved. Well, the thing, GC, a little bit difficult to understand what exactly you have done. But the thing is, if you are using AutoFS on the home folder, then you don't have access to the original content of the home folder anymore. And that is like mounting a device over a device that is already mounted. You don't see the original content anymore, and that messes up everything. That is also why in the AutoFS demo yesterday, I have created a subdirectory. So we weren't working on /home, but we were working on /home/LDAP and subdirectories in there. So I guess that's a pretty important one. And maybe that explains what is going on. It's always difficult what's happening based on the information that you are providing without seeing your system, but I would analyze it in that direction, GC. And hopefully that is going to help. By any means, there is one thing about AutoFS that is a little bit weird, and that is this permission thing. The thing is that your folders have a UID as owner. I think this is an interesting one. Let me check on /home, and let me do a user del Bob. Now let's go in the home directory and let's do an ls-l on this directory content. And what do we see? We see that the home directory has an owner, and the owner is 1001, and the group owner is 1001. So in the inode, in the file system administration, you have the owner that is written. And this owner, through etc pass wd, resolves to a local user. Now, if you are going to really set up an environment for home directories, then on your NFS server, you need to make sure that the correct user IDs are owner of that home folder. That involves a lot of manual synchronization. Thank you very much. I'm not showing my demo terminal. That is correct. Sorry for that. Let me bring it up. So that involves a lot of manual synchronization. Here you go. That's what we just missed. You should see it right now. And that is not so very cool. But AutoFS was never really developed as a solution that is used on its own. AutoFS was developed on a solution that works together with NIS in the beginning, the Network Information System Services, and later with LDAP. Now, what is the idea? You create an LDAP server, and in this LDAP server, you create your users. You configure every single Linux server as a client to the LDAP server, and that makes that user ID 1001 on your NFS server is the same as user ID 1001 on your client machine. Now that is something that in our case is absolutely not going to happen. First, the exported home folders, I created them as root, so all owners are set to root. And that is sufficient for my demo, but that doesn't give us real ownership. And secondly, If on the NFS server you make sure user 1001 is the owner, well, you access the same directory from the NFS client through the directory information. This UID 1001 is going to be found, and what is going to happen? It picks up user 1001 from your local machine, and that is going to create nothing but confusion. Now, this is a little bit of background information. Uh, my most important advice, don't worry about it too much, because on our HCSA you are definitely not going to do to get this deep, but it is sure something that you need to be aware of. I hope that helps, and I hope that explains a little bit what was going on, GC. Let's go over to the topics of the day. Time to start with. What do we need to know about time on Linux? Well, first, when you boot, the system gets time from the hardware clock. The hardware clock originally was the BIOS clock, which was backed by small battery. Now, based on your hardware clock, system time is set. So your operating system loads and your operating system is getting the time from the hardware clock. And as long as your hardware clock is accurate, there's nothing wrong with it. But you can probably guess that if your hardware time is not accurate, then you are going to get trouble. And that is why internet time nowadays is currently involved as well. So what do we do with internet time? Well, you are going to synchronize your system to an internet time source. That's a server on the internet, and your system is getting the time from the internet. And that is more accurate because, yeah, internet time is very well synchronized using NTP. Now, this internet time is normally what you bring up later. So normally you boot, you get the time from your hardware clock, you load your operating system, and once your operating system is loaded, the system time is going to synchronize using NTP with internet time. Now, there's a couple of commands that is involved. First command that matters is HW clock. Why would you want to manage your hardware time? Well, for the simple reason that if your local time is off too much from the internet time, NTP is going to consider your local clock to be insane. And if you have an insane clock, there won't be any time synchronization. The limit is 1000 seconds, so if there's more than 1000-second difference, you won't get synchronization. Now, this is a symptom that can happen on computers that have a broken hardware clock. You have probably experienced that you are turning on a computer that hasn't been used for 3 years or so, like an old laptop that you find somewhere. You bring it on and it gets to a time like January 1st, 2000, or even worse, January 1st, 1981 or something like that. That's what is going to happen, and NTP is not going to synchronize that all right. And that is one use case why you would want to set HW clock. You can also use HW clock to synchronize time. That is synchronize time between system time and hardware time. And folks, for your information, I'm looking at the slides. You want to follow along, make sure you see the slides as well. So you can do stuff like HW clock sys to HC, which is synchronizing system time to hardware clock, or HW clock HT to sys, which is synchronizing hardware clock to system time. So that would also be an option to set your time if it is not all right. You use a command like date. Date is how you show and set system time. After setting your system time with date, you can use HW clock minus sys to HC to ensure that everything is going all right. YK is saying, I can hear anything. Well, I think YK, you mean I can't hear anything. Can somebody post if I'm audible, or let me know if you can't hear me as well? Time date CTL is also useful. Time date CTL is the utility, the newer utility that is used to manage time and time zone configuration. It's a more advanced utility. Right, and thank you, folks, for letting me know that sound is good. Now, how about time date CTL? Time date CTL is the newer utility that allows you to manage all aspects of time. I would suggest don't spend your time using date, use time date CTL instead. Like time date CTL status, which will show all time properties that are currently used, or time date CTL set time, which is what you can use to change the time. You can even manage time zones in an easy way using time date CTL set time zone. And time date CTL set NTP is used to enable or disable NTP synchronization. Now, how about NTP synchronization? If you want to synchronize time using NTP, you need an NTP service. And the interesting thing is that in current Linux, there is no less than 3 different NTP servers that are available. There's NTPD. NTPD is the legacy NTP service. There is ChroniD. ChroniD is what Red Hat is using for time synchronization. And there is also systemd timesync-d. Now, systemd timesync-d is not supported on Red Hat, and that's something you definitely need to be aware of. Because if you are trying to synchronize time and by accident you are going to work with systemd timesync-d, it's not working. RHEL 9 uses Chrony. So you need some minimal knowledge about Chrony. And above all, do remember that systemd timesync-d service is not currently used on Red Hat Enterprise Linux. Now, for the exam, and that's the reason why we are here, for the exam, you need to be able to manage an NTP client. Managing local time is a very important skill, particularly when solutions like Kerberos are involved, because Kerberos is using timestamps, and these timestamps need a time that is pretty accurate. So managing NTP client is important. So what is there to know? Well, you should know that ChronyD is the default RHEL 9 NTP server. And you should also know that the time date CTL command set NTP service is not going to work. That is confusing because you are going to think, hey, there's this new and cool utility time date CTL, and time date CTL is taking over everything. Well, time date CTL is taking over almost everything. You cannot set an NTP server with time date CTL. ChronyD is what you are going to use. It's not really very hard. There's a chrony.conf. In chrony.conf, you can specify a pool. A pool is a group of NTP servers. So you put pool 2.rel.pool.ntp.org followed by iburst to configure the pool of NTP servers. iburst is an option that is relevant for virtualized operating systems. A hardware clock in a virtual environment behaves a little bit different from hardware clock in a physical environment. In a physical environment, if time is off, you are going to speed up or slow down your hardware clock, and that doesn't work very well if you are in a virtual environment. And the fun thing is that most Linux servers nowadays are virtual environments. And yes, when I say so, I'm also thinking about cloud instances, which in fact is also virtualization in some way. So consider iburst to be a mandatory option and make sure it exists. Apart from the pool option, there's a server option, and the server option allows you to configure a single NTP time source. Now, this is stuff that is important enough to have a look at the chrony.conf so that you know where to find it. After you have set your time through chrony.conf, you need to restart the ChronyD service, and you might want to check out the chronyc sources command. Let me show you a little bit. Enough talk about what is on the slide. First, time date CTL. Tab completion is showing all the different options, and let's use time date CTL show, and that will show us what we are currently doing. So I'm in Europe, Amsterdam time zone, and local RTC, that's local real-time clock, is set to no. I don't have a hardware clock, and it knows it's NTP synchronized. More or less related is time date CTL status, and in time date CTL status you can see the current time. You want to set time, you can use time date CTL set time. Do we have a -H on that? And oh, that's too bad. It's not really telling us what to do. Yes, set time, set system time. I think the intuitive time is going to work here. Alternatively, you don't have to use time date CTL. Feel free to use date -S to set your time. Now, the important thing, as I just mentioned, is the etc chrony.conf, where you have these options. Default option is pool. This is how you configure the pool of time servers. This is also the only thing that you need to know for RHCSA. You need to know how to redirect your time client to a specific server. That's a fun thing about RHCSA. RHCSA is really about rel as a client, and not about rel as a server. So I would love to tell you about awesome options like the allow option and the local stratum option, but honestly, nobody cares. The only thing you need to know is to configure your server to fetch the time from somewhere else. Once you've done that, you can use chrony C sources. And chrony C sources is giving you an overview of all the different time servers that you are currently synchronized with. And here we have the list, and what you want to check is this millisecond thing, which is showing the difference in milliseconds between your time and the time server in question. What you also want to check is the stratum. The stratum of the time server indicates the reliability of the time server. The lower the stratum number, the higher the reliability. So this ntp4.bit.nl is the most reliable of the time servers that I'm working with. But to make sure that if that server is going down, there are other servers that can still help me. There's a couple of Stratum 2 servers as well. And yeah, that is all that I need to tell you about time synchronization. Now, I know you don't want to hear about time synchronization. You want to hear about containers. And I have good news. We only have to talk about scheduling tasks, and then it's time for containers. So let's do scheduling tasks. What is task scheduling about? Well, it's about making sure that the process or command is started at a specific moment in time. And how are you going to do that? Well, you are going to use different solutions. The first solution you need to know about is the systemd timer. Systemd timers are the primary solution for scheduling recurring jobs on RHEL 9. Until and including RHEL 8, cron was the default for scheduling jobs. In RHEL 9, the systemd timer has become the default, so your way of working really is different. So cronD is the older scheduling option, still supported, and might be a bit easier to schedule custom tasks. Warning, even if RHEL 9 is defaulting to systemd timers, the exam objectives specifically mention that you need to know how to schedule a job with cron. So make sure you know how to do it with cron. It's kind of a funny situation because formally Red Hat is only interested in the solution, and they don't care how you get to the solution. But if it's about scheduling jobs, you need to do it with cron and not with the systemd timer. Be warned. I think the phrasing of the potential exam question should be obvious enough to avoid any doubt about it. But yeah, pay attention to it. Now, AT or AT is available to schedule non-recurring user tasks. So let me show you a quick example using AT. Right now it's 4 p.m., so I am going to use at 8 p.m. That's a pretty intuitive prompt, and I am going to use power off at 8 p.m. There we go, using Control D. And Control D is scheduling my one time only job for 8 p.m. This evening, which is in my time zone when this class is going to end. All right, let's talk a bit about System D timers. And folks, make sure that you see the slides. I don't know how you are working, but I always advise double click on the slides icon, move it to the upper right corner so that it doesn't hide too much of the screen behind it, so that you can see my screen and the slides at the same time. And hey, you know what to do about the gray bar that is hiding the last line on the terminal that I'm sharing, right? You need to move your mouse cursor out of the shared terminal, and then you will also see this last line. Now, about System D timers, we have timer units that go together with service units to schedule the service file. Quick demo. When I use systemctl list unit uh, unit uh, unit files, and I'm grabbing on fstrim, then what do we see? We see that there is an fstrim timer, there is an fstrim service. Background information: fstrim is a service that optimizes your your SSD devices. And it is, if you are using SSD storage, it's really recommended to use fstrim once a week or so. So how does it work? Well, we have fstrim service and fstrim timer, and fstrim timer is triggering the fstrim service. If you are going to use systemd timers, the first part of the name must match. In the fstrim timer, you will find nothing that is connecting it to fstrim .service. It is name based. Good. What do we see? If we use systemctl cat on fstrim .timer, we see that we have a timer setting, and this timer setting is running it on a weekly basis. That's the only thing that matters. The accuracy sec and the persistent and the randomized delay, that's not so interesting. The interesting part is on calendar is weekly. If I use systemctl status on fstrim.timer, then we can see that it is loaded. Loaded just means that systemd knows about the configuration file, which is userlib systemd system fstrim.timer. It's not doing anything. And if you want to enable this thing, the thing that you enable is the fstrim timer. So I'm using systemctl enable minus minus now fstrim.timer. There we go. So now the timer is running, and let's do a status on fstrim.service. And what do we see? We see the service is inactive, but we also see it is triggered by fstrim.timer. And that is what you need to know. Now, about these timers, in previous versions of RHEL, it was all cronD, taking care of automatically scheduled jobs. But on RHEL 9, there is not so much cron anymore. It has all become timers. A relevant command is systemctl list units minus t timer. That's showing all the timer units that are currently activated, like log rotate, for instance. And you can even see how often it is working. So this is the important thing to know about it. Now let's get back to the slides to give you a little bit more information. So when you are using systemd timers, the timers should be enabled and started and not the service unit. Systemd timers are often installed from RPM packages, but you can also create them yourselves. In the timer unit, you can use the on calendar option to specify when the service should be started. And the on calendar option is a very rich option that allows you to specify in many, many ways how to start your service. I have a slide about it in just a minute, but first, let's do another one, the demo. I'm going to walk you through the demo. So we already use list units, systemctl list units minus t timer, and we see all currently active timer units. Now I'm using a systemctl list unit files. And yes, I forgot about it. I automatically grab, That's the Linux philosophy. You don't need one command that can do all, but you need many commands that are specialized in what they are doing, and you combine them in pipes. And I can't get used to one command that's doing everything, like systemd. But here we see log rotate service as well as log rotate timer. Systemctl status on log rotate dot service is giving me what? Is giving me a triggered by option. And the triggered by option, that is what it's all about. And obviously log rotate dot timer. Well, let me also do that. Systemctl status on log rotate dot timer is telling me that it is active and it is waiting since Wednesday, that was yesterday, 7:26 CET. So apparently at 7:26 it is going to run again. Now you can also do it yourself. If we are going to use dnf install -y sysstat, then you are going to install the sysstat package. Maybe you have heard of SAR. SAR is a System Activity Reporter. It works on data that has been collected by sysstat. Sysstat is you're running a couple of processes, and it writes system performance-related data, and the SAR utility is what you can use to figure that out. SAR -a is giving me nothing at all. And why is SAR -a giving me nothing at all? Well, that is for the very simple reason that sysstat hasn't done its work. Now, if we do a systemctl list unit file sysstat, now what do we see? We see that there is some sysstat stuff and a sysstat collect timer that is enabled. So that is good. And if we use systemctl cat of sysstat collect timer, then what do we see? We see on calendar every 10 minutes. So can we trigger it? Well, you can trigger it. It is just triggering the sysstat service. What is sysstat service? To give you a little bit more insight, systemctl cat on sysstat.service, and there we can see it's just a program. It runs a program. So if you really want to run it right now, it's very simple. The type is one shot, and one shot means run it now, and then the service will stop again. So systemctl start sysstat.service will do the gathering. And now if I use SAR -uppercase A, I do get information. Use SAR --help for much more information about what you can do with SAR. Really, I don't want to talk about SAR here. So JS, I think I just answered your question. And GC, yes, you can wait. By default, it's 10 minutes. 10 minutes is acceptable. If you don't want to wait 10 minutes, then, well, as you have just seen, manually started. It's also cool, by the way, that while doing this demo, you have seen that systemctl service, I should rather call them systemd services. Systemd services is not just about daemons. Any command can be used, created as a systemd service. All right, what is next? Well, next we need to talk about timer activation. So I'm back on the slide where we can see that systemd timer as an on-calendar option, and this on-calendar option uses so-called rich language to express when the timer should activate. So on-calendar is *:00/10. We'll run it every 10 minutes. You can also do it more complex. I really use a ridiculous string here just to show you how powerful it is. So this string is for every day in 2023 at 9:09:30, 9:19 and 30 seconds, and 9:29 and 30 seconds. Systemd timers have another cool thing, and that is on unit activate sec. So on unit activate sec will start the unit the specific time after the unit was last activated. So that allows you to run a unit every 3 hours if you want to. And you have on boot sec, which is more or less the same as on startup sec, which starts the unit specific time after booting. So you want to run a specific unit half an hour after booting, this is what you need. And that's also kind of cool because this avoids your system once it has booted to do everything. I know you have all seen Windows booting, right? What is Windows doing if it boots? Particularly if you haven't booted it for a long time. Then suddenly it's starting a million services and it will have you wait for an hour or so until all of these services are done. And in the meantime, you can't do anything. Windows should use systemd. Then I can use this on startup sec and gradually run your services sometime after booting. Hey, Windows is becoming the new Linux anyway, so who knows? That might be happening. Right, if you want to know more about time format, you have man 7 systemd time. There's also man 7 systemd timer, not to be confused. That's kind of cool. Man 7 systemd on any unit type. Do a systemd path, for instance, if you want to know. Really? Systemd, I think that's a hyphen. Yeah, there we go. It's a hyphen. Do I have a dot on the slide? In that case, I need to tweak my slide. No, I don't have a dot. I just can't read. Okay, so any unit type in systemd has its own man page. Do not forget about systemd directives. We talked about it earlier, but in systemd there are so many things that you can check. And if you find one of these directives and you have no idea what it is, then systemd directives is telling you for a parameter which man page it is further documented. Really, this is one of the most useful man pages on your entire system, systemd directives. Right, quick demo. Why am I using a systemctl daemon reload? Really, I don't know. And oh, that is because of this stupid demo that I don't want to do. It's in the recorded video, of course, it's too much. You don't need to know how it works up to that level. We need to talk cron. What is cron? Cron is the old Unix scheduling option. It has been around since the earliest days of Unix. Cron uses cronD, and cronD is a daemon that checks its configuration to run cron jobs periodically. The main configuration file in cronD is etc crontab, and in etc crontab, well, nothing is scheduled anymore because now we do it a little bit more sophisticated, but what you see is a quick explanation of how it works. I kind of like this because if you forget the 5 positions, the 5 stars in the highlighted lines, if you forget the meaning of the 3rd position, for instance, here you have some essential documentation about how it works. And that is kind of cool. Still on RHEL 9, cron D is enabled as a systemd service by default. The fun thing is, with the transition to systemd is taking over an increasing amount of stuff, but even while taking over an increasing amount of stuff, the old solutions often stay around for a bit. So cron D is still enabled, is still running, and is still making sure that if you are creating cron-based services, it still works. And honestly, I don't think that's bad because, hey, why would you want it to fail? Because suddenly you have changed the standards. If, however, you look at cron, cron works with etc crontab, and cron etc crontab has this etc cron star directories, and we have cron D, etc cron D. That's an extension to etc crontab. There is one thing in there, and that is what is needed by cron.hourly, and for the rest of cron.daily, cron.monthly, cron.weekly, they are completely empty. So if you would look on rel 8, in rel 8 you see quite a few cron jobs that are scheduled on a daily basis through etc cron.daily. They are not there anymore. They have all been converted to systemd timers. But you can still use it. And if you do, cron hourly, daily, monthly, and weekly are kind of cool. You just drop a script in there, and this cron service will make sure it runs every hour, day, month, or week. This is perfect if you don't really care about when exactly it is going to be started. And another thing that you can do with cron, and I probably have that on the slide, is create user-related jobs. And that is something that I consider important. What do we have on the slides? On the slides, yeah, user-specific jobs can be created using crontab minus E. So how does that work? Crontab is the cron editor. Crontab minus E is for edit and minus U is for user. So let me use crontab minus E minus U Linda, and that will create a contact file for user Linda. And what am I going to do? I am going to use */2 *** logger Linda was here, which is going to run this job every 2 minutes. Cron should pick it up pretty fast. So let's use journal.ctl. Logger is writing to the journal.ctl, right? And there we can see that my command was successful. So as user Linda, the command Linda or the text Linda was here was written to the syslog. TL wants to know if it is possible to run something every 3 hours. Yes, you can. If you want to run something every 3 hours, then the string that you are going to use looks like this. */2 is not really making sense. You would use 0 */3 ***. That is for every 3 hours. Oh. If you are going to set cron jobs to run every 3 hours, do not forget that you need a specific value in the minutes, because if you don't do that, if you leave the minutes to star, then it will run every 3 hours on every minute in that hour. And that's probably not what you want to do. All right. Do I need to tell you anything else about cron time specification? I don't. I think we are done. I think we are going to start with the topic of the day, which is containers. Folks, I'm going to send you the so-called pulse check. That's a thumbs up, thumbs down. I want you to send me a thumbs up if you already are comfortable with containers. I want you to send a thumbs down if you don't know anything about containers. Nowadays, many people have at least started the Docker container a couple of times, but if you have not, then that is nothing to be ashamed of. Even better, your answers are going to be anonymous, but I want to know what the current situation is. And all right, I see big majority already for not comfortable with containers. Folks, what we are going to do here, I am going to introduce the Red Hat solution for containers. If you want more details about containers, come back next week on Friday when I'm teaching containers in 4 hours. In fact, I would recommend that we spend the entire next week together. I don't do this often, but I think every single course I'm teaching next week is relevant if you want to deepen your knowledge for RHCSA. On Monday, I'm teaching Linux under the hood. That's going more in depth in the Linux operating system. Linux performance optimization on Tuesday. Linux troubleshooting, which is an awesome class, only 3 hours on Wednesday. Linux security, brand new class, 5 hours in total. On Thursday and on Friday, containers in 4 hours, which, by the way, is a class that I'm focusing very much on uh, on Podman, on Red Hat containers. Uh, what I normally do in containers in 4 hours, I explain to people why Docker really is not a good solution. There's a huge problem in Docker. You can easily take over a system if you are running a Docker container. And B, I suggest you just look me up in the calendar. I'm not going to post these classes right now, maybe later, but if I do that right now, that would waste 5 minutes of our time that I can use in a better way. Look me up in the calendar and you will find them. And later I will have a little bit of time. I will create a resources.txt file and update it and share it with you later. So troubleshooting, we already done our troubleshooting. So that's not what we need to do. Containers, that's what we need to do. I am going to consider you guys newbies in containers. So I'll start with an introduction, and I am going to tell you what a container is. Well, no, let me follow the slide. Uh, Container is like an application on a smartphone. It's a new way to start apps, and a container is a package that contains all that is needed to run an application. Let's check how it worked in the old approach. In the old approach, you would install an application on your computer. If you install an application on your computer, there may be a couple of challenges. Challenge number one, your application has dependencies. Hey, you need to install .NET 3.5. Challenge number two, your application has a dependency that is conflicting with another dependency that is already installed. You have installed Python 2.7 and you need Python 3.8 to run your application. That doesn't go together. Other challenges, like you have a Windows application, but you are running a Linux computer. All of these challenges are fixed when you are going to use containers. As I told you, container is like an application on your smartphone. You fetch the container image, you run it, and it's a done deal. Now, one of the very nice things about containers is that your containerized application, this image, is highly standardized. And because it is so very standardized, you can run the same container image as easily on your Linux computer, on your Windows computer, as on a cloud platform. And for that reason, containers really are an awesome way to run applications. So on the slide, I mentioned this makes containers a solution for the dependency challenge. Because what are you going to do in a container? In a container, you are going to make sure that all of the dependencies are in there. So you have your application. Your application depends on Python 2.7. You just put Python 2.7 in the application. JS, there's only one dumb question, and that's a question that you don't ask because you probably will never know the answer. So JS is asking, are containers always command lines, or do they make GUIs like launch when you launch a virtual machine? Containers are most of the times services. If you want to talk about containers on Linux, and that is what we should be doing, your container on Linux is a service, like a web service. And in case you think, hey, didn't we have systemd for running services? Yes, I would say we have systemd for running services. I'm not so sure that 10 years from now, systemd will still be as significant for running services as nowadays it is. But hey, JS, if I make the statement that what you do on your smartphone when you run an application, your smartphone applications do provide graphical user interfaces, okay? But if you look at Linux, the best way to see a Linux container is as a service. It's a process that you want to run in an isolated environment. So for the remainder of this talk, I will focus on Linux containers, and I will leave the smartphone applications alone. Now, containers, I started from container images. And container images, that's the distribution model. And we will discuss how easy it is to make container images for your custom applications. The nice thing is you can very easily create your own image, and even better, you can put your image in a so-called container registry. And if you put it in a container registry, you make it available to anyone on the planet. So it's a very nice, very easy distribution model. And all of that makes that people are quite excited about containers. Now, yeah, images, these container images are provided through image registries. Now, containers come forth from the Linux operating system. Containers are Linux. And fun fact is that even if you are running containers on Windows, Windows, since a couple of years, has this thing called WSL, the Windows subsystem for Linux. And this Windows subsystem for Linux is a Linux virtual machine integrated in the Windows operating system to allow you to run containers. Isn't that cool? And that's why I say containers rely on features that are provided by the Linux operating system. These features are control groups. So control groups set limits to the amount of resources that can be used. This sounds really dumb, but originally an application can claim all memory that is available on the host operating system. That is so dumb that since 2006, we have C groups as a Linux kernel feature, and you can use C groups to set the limit to the amount of resources that can be used. So you want to make sure that your application can't use more than 4 megabytes of RAM. You got it. C groups are taking care of it. Containers also provide namespaces, and a namespace is isolation to ensure that the container only has access to its own data and configuration. How would you do that? Well, let's say you have a container that runs a web server. Then the container needs access to some shared directory. And in the shared directory, if you would access it from within the container, you only see the web server files, nothing else. Compare that to running a web server as a systemd service. If something goes wrong and an evil intruder comes into your system and is trying to hack your system, the intruder would be able to see all files on your entire system. Containers have namespaces, and these namespaces make that from within the container you can only see the container files, you can only see the users that are relevant for the containers, you can only see the processes that are relevant for the container, even if the container is still running on your host operating system. And these namespaces are really an important part to make your containers secure. If you are running your containers on Red Hat, we have this beautiful thing called SE Linux, and SE Linux enforces security. I will show you how that works in the container in just a little bit. Good. Then we have the rootless container. What is a rootless container? Well, the thing is that containers need a user ID to be started on the host computer. And this user ID is, well, the ID of the user that originally started the container. Maybe I should start by telling you about Docker. A quick demo, quick drawing about Docker. So let me open the drawing application. Drawing application Rob coming up right now. Still working on it. Enjoy seeing the Greenlandic ice cap, which is over now, because here is the drawing application. How does it work in Docker? Docker was the original solution that made containers great on Linux. In Docker, you have the Docker D. And Docker D is a daemon process. It's a systemd started daemon process. And this daemon process runs with elevated privileges. And elevated privilege is really like sudo privileges. It runs with root privileges. And this Docker daemon, yeah, it's a root process. if you check the user account that is used by the Docker daemon, it's the root process. Now, if you are a user in a Docker environment, so let there be no mistake, this is Docker. If you are a user in a Docker environment, well, your user first needs to be a member of the group Docker. Without it, it won't work. And being a member of the group Docker, the user can communicate to this Docker daemon, and this Docker daemon will run the container. Now, the problem is that the Docker daemon that runs with these elevated privileges runs a container, and as a result, if you don't be very careful about what you are doing, your container runs with root privileges as well. And that can be extremely dangerous for your system. And that is why Red Hat has Podman. Now, how did it work? Honestly, Red Hat was quite happy with Docker in the days of Red Hat Enterprise Linux 7. What Red Hat didn't like so much was that Docker was owned by Docker Inc. That was a company, and this company had their own objectives in making money. So that was one reason why Red Hat has been looking for an alternative solution. The other reason why Red Hat was looking for an alternative solution was technical. And they found the Podman project. It's not fair to say that Podman is a Red Hat solution. No, Podman is an open source project that was integrated in Red Hat starting Red Hat Enterprise Linux 8. And it's a replacement of Docker. They are fully compatible. So all Docker containers also run in a Podman environment. But what is happening in the Podman environment, instead of the client-server model that Docker is using, Podman is using the fork model. And that means that in Podman, any user can run a container. But hey, the only limitation is that if you are a user with limited privileges, there's a couple of things you can't do with this rootless container. Rootless containers have a couple of features. First, no access to all files. Sometimes people say that rootless containers have a couple of disadvantages. Do you really think it's a disadvantage that the process that you are running doesn't have unlimited access to all files on your system? I hope that you can answer that question yourself. Of course it is not. Rootless containers cannot bind to a root port. That's also not really a problem. So that means that a user cannot start a rootless container that is going to bind to a privileged port. That's a TCP or UDP port with a number lower than 1024. But that should hardly be a problem because the processes can just be started in another environment. The nice thing about these rootless containers is that the rootless containers are much more secure than the Docker containers. And that is why Red Hat started making Podman big, and other distributions nowadays are also running Podman. That's what I wanted you to know as background information. Let me get back to the demo system and the slide as well, but I first want to show you the demo system. There we go. And now let's do slide. So summarizing what is happening with these rootless containers. Well, containers need a user ID to be started on the host computer, and root containers are started by the root user, and they should be avoided. In a Podman environment, now in a Docker environment, all containers by default are root containers. In a Podman environment, a container only becomes a root container if it is started by the user root. And rootless containers are started as a non-root user. The rootless container is the standard. So rootless containers can even generate the user ID dynamically or pre-configured to use a specific user ID. In the end, it's like running a process. And you know, if you run ordinary processes on Linux, for ordinary processes on Linux, you can also give them their own limited user IDs. And that is exactly what you are doing with these rootless containers. Give it its own user ID. It can be generated automatically. You can set it yourself, whatever you want. And yeah, they do have a few limitations. No unlimited access to the file system. Call that a problem. Can't bind to privileged network ports. Why would you want to do that? Good, let's talk about Red Hat container tools. Folks, I'm still looking at the slides for your information. So we have Podman, and Podman manages the containers and the container images. So if you want to compare it, Podman is the command that is the drop-in replacement of the Docker command. The funny thing is that the Podman project it has made the Podman command completely compatible to the Docker command. Because at the moment that Podman started, Docker was the dominant solution. People wouldn't ask, are you running containers? No, they would ask, are you using Docker? Docker and containers was just the same. So Podman wanted to get its part of that market. And in order to get its part, they decided to create a command line interface that is fully compatible to Docker. And that means that any command that starts with Docker as a Podman equivalent. And it's even so that if Docker introduces something that doesn't work in Podman, Podman considers that a bug and they give it the highest priority. And B, you are right. General rule of don't run as root applies to containers. Yes. In general, there is no reason why you would want to use root privileges. Other tools, less important, are Builder. Builder is an advanced tool to create container images. There's also Scopio, which is an advanced tool to manage, copy, delete, and sign images. You won't see Builder and Scopio anymore in this class, but I wanted to mention them. Podman is what it is all about, and Podman is a default installation. I think they are even in a minimal installation. It's a part of the default Red Hat installation. You will always have Podman. And as I already mentioned, Podman has also found its way to other Linux distributions. Right, now if you are going to work with containers, an essential part is the images and registries. Node.js, we won't use Scopio. So container images are used to package container applications with all of their dependencies. You know what? I am going to run an example, but I'm going to exit my root shell because we are going to do rootless containers, right? I'm going to use Podman run nginx, and let's see what is happening. For those of you who have worked with Docker, you can see something that is already happening. If you are using Docker, in Docker there is only one image registry that matters, and that is Docker Hub. Docker Hub is the third image registry that is listed here. One of the things that is really interesting with Docker, as they were the de facto standard for running containers for quite a long time, people that developed container images have massively provided these container images on Docker Hub. There are no official numbers, but it's more than 10 million images that are available on Docker Hub. Now, for Red Hat, it's kind of funny if they are going to tell their users, hey users, you should use containers in our trusted platform. You know, Red Hat is used in big corporations, so trust and security is really a big feature. And then they are going to use these Docker containers on Red Hat Enterprise Linux. That is weird. And that is why Red Hat also has a couple of image registries. We have registry.access.redhat.com and we have registry.redhat.io. Why? Well, for content that has been verified by Red Hat and that has been optimized for Red Hat. Now, what is happening here? I'm using Podman run nginx. And the fact is that in Red Hat, we do not have a default container registry. In fact, Red Hat wants us to use something like and let me Control C out of it, like podman run docker.io slash library slash nginx. That's a typo. Let me fix that. This is the fully qualified image name. And the fully qualified image name contains an entire path to the registry. It's a little bit like the way how you are using files. Files have an absolute file name, containers have a fully qualified image name. And since Docker is not no longer the dominant solution in the world of containers, you shouldn't assume that you want to run your containers from the Docker registry. So Red Hat wants you to use fully qualified image names. Now, what has just happened? Let's just analyze the output. It has first pulled the docker.io library nginx latest. So it has reached out to docker.io because I told it so, and it has looked up the nginx image, and it has copied the nginx image to the local system, and then it has started the entry point. Entry point in containers is the terminology for the default application. Because don't forget, a container is absolutely nothing like a virtual machine. A container is a fancy way to run an application. And which application that is what you are going to specify in the entry point. And that's what you see right here. And oh boy, I also see that I'm not getting my console back. Why is that? Well, that is because I didn't tell my Podman stack to run the container in the background. Let me use podman run minus D to run the container in the so-called detached mode. That's also the point where I'm going to wrap it up because I think it's time for break. So it's still running the container. We can verify that using podman ps. There you can see the running container, but it is running in detached mode. In detached mode, that means that really it is running like a daemon in a Linux environment, and it's not occupying your console anymore. Talking about occupying, I am going to occupy my coffee machine. Folks, it's time for coffee. And here is the user student history. We haven't done that much yet about the containers. Uh, I would say go have a cup of coffee. I'll see you in 12 minutes. Enjoy and talk to you in a bit. Hey, we are stopping Docker, and from now on you have to use Podman even the images that you will find. Hi, folks, I'm back. So before the break, you have had for first impression of what to do with a container. Let's continue. And I'm continuing on the slides you started. So container image, that's a key part in working with a container. You use it to package container applications with all of their dependencies. And images are built according to the OCI. OCI is Open Containers Initiative. Open Containers Initiative, in fact, is something very cool. When Docker started with containers, we are talking about the year 2013, so 10 years ago, they also started the Open Containers Initiative. And the Open Containers Initiative is a standardization organization with the mission to make sure that containers are interoperable. Now, the nice thing about container images, even the images that you will find on Docker Hub, is that they are OCI compliant. Podman containers are also OCI compliant, and that means that you can run a Docker container image without any conversion, just straight in a Podman environment. And that's pretty cool. So, yeah, that is also why when Red Hat announced, hey, we are stopping Docker, and from now on you have to use Podman, that was not a problem for their customers. Because it's just a replacement of the binary. And if you run the Podman binary instead of the Docker binary, it is going to work. Now, as we have seen, containers are offered through registries, and you need to be able to use these registries. You can use the Docker Hub, you can use private registries, or you can use registries for the Red Hat world. One container registry that's definitely worth mentioning is Quay.io. Quay.io is a Red Hat sponsored project, and on that registry you will find a lot that has been optimized to use to work in a Red Hat environment. Now, Red Hat themselves distribute certified images that are accessible only with Red Hat credentials. That's the point. Red Hat is offering support. Red Hat is selling support. And in order to get your support, you need to make sure that Red Hat has full control over them. Red Hat is not going to support any Docker Hub images. They have their own. And that's registry.redhat.io. And oh, this is an old one, registry.connect.redhat.com. It's access.redhat.com. But hey, you don't care about these registry names, because these registry names, you will find them back in the container software itself. Let me show you. When I use cat on etc containers registries.conf, this is the main configuration file for the registries. I should have used less. Let me correct that, because I'm interested in this line, the unqualified search registries. And what is that? Well, unqualified, that doesn't mean that you shouldn't use them. It only means that these are the default registries that Red Hat is going to check if you are using a container image. So when you use Podman run Nginx, that's an unqualified image name, and Red Hat will check all of these registries. And if it's not sure which one you need, then as we have just seen before the break, it will prompt, hey, which of the following registries do you want to use? And this is what can be used. Now, in RHEL 8, I would tell you, you have to change this file to include the registries that you want to search. In RHEL 9, there's no changing of the file, because the recommendation is to use qualified image names. Now, how are we going to access Red Hat registries? Well, in order to do so, you need a Red Hat account. The developer account does qualify. And you need to log in. This is a skill that is definitely required on the exam. Without logging in, no access to your registries. So I can use Podman login, to log in. That's according to how you would do it in a Docker environment. Docker, it's no different. You know, in Docker, they now have this pull rate limitation, and if you do an anonymous container image pull, you might hit a limitation. And if you want to go beyond the limitation, you need login, Podman login of registry.redhat.io. It's doing what? It's prompting me for my username. It's prompting me for my password. May have a typo here. Yeah, that's what I was thinking. Should never talk while entering the password. Particularly not when the password is not your default insecure password. And here we go. Here we have this login. Now, a couple of questions about the login. SJ wants to know, do we need a Red Hat account for the exam? No, you don't. On the exam, it is likely that you have to log in, but the only way will be to provide an account for you. TL wants to know, we need to log in when we run a container from a container file. Well, a container file is what you use to build your own container image. And you always build your container images on one of the base images. And if you want to fetch these base images from a registry that requires authentication, you need to log in. And yes, as GC is mentioning, it's supposed that the VMs are isolated, no access to Red Hat. Everybody, you need to be prepared for some proxy-like environment, and you need to be ready to use the Podman login command. I just did, and it is really pretty simple. And hey, don't worry about it. If you are trying to fetch an image from a registry that requires login, it will tell you, hey, this registry requires login, and that should not be too complex. Now, this slide is a little bit obsolete because it's telling us that registry access is configured in etc containers registries.conf. It's kind of true because we have these unqualified search registries. You can even create a specific registries.conf in the user environment. Now, this is interesting enough to mention. The user in the home directory has .config/containers in which you can put a registries.conf if ever you want to override anything. I don't think this is something you should worry about too much. What you should worry about is that you use these fully qualified container names. We talked about them already. Using a fully qualified container name, you don't have to configure any registries at all. Now, the signal that Red Hat is sending to the market right now is use fully qualified container names. So it's very unlikely that you need to configure registries. Now, talking about images, as I told you, you can build your own images. And how are you going to do that? Well, by using a container file. Container file, I'm calling it previously known as Docker file. Well, for the Red Hat universe, that is true. For other container environments, that's not really true. But hey, a container file is a text file with instructions to build a container image. Now, when Docker created this, they called it the Docker file. But nowadays, in Red Hat, you don't use Docker anymore. And for Red Hat marketing, it is really important, as they call it, to undockerize containers. So they renamed a couple of things, and this couple of things includes the Docker file, which is now called a container file. And in a container file, you will put instructions to build a container image. And container files have instructions to build custom containers containing your own software based on a base image, such as the UBI image. You need to know about UBI. UBI is the Universal Base Image. And that's a base RHEL 9 image that you are going to use for all the containers that you are going to use. Red Hat is using them. You can use them as well. Between you and me, I don't like UBI because UBI is a relatively heavyweight container image. If I'm building my own container images, I'm going to use a universal lightweight like BusyBox. BusyBox is awesome, and well, it's only 8 MB. Build your application on top of that. You get small container images. Build it on top of UBI. You will get big container images. Alpine is another alternative. Alpine and BusyBox are commonly seen. I'm going to show you how to work with a container file. And GC has a question before we go there. If there is a registry inside the network, can we just use Podman login? Yes, you can just use Podman login. Or should we before edit in this registries.conf? Well, Podman login is how you authenticate. If you want to include it in the unqualified search registries, then I would add it to the unqualified search registries as well. Because GC, these are two different problems. Podman login doesn't take away the need to use a fully qualified image name. If you want to help Podman a little bit and include this registry in the list of registries that it is going to search when you are using unqualified names, then put it in the registries.conf. But I repeat, using a registries.conf is not the recommended way. Okay, I'm going to use sudo dnf install container tools. Am I going to do that? No, I'm not. For the simple reason that Podman, and let me use Podman info, Podman is a part of the default installation. There's no need to install anything. What I want to show you here in this Podman info is the 3 lines on the top. These 3 lines on the top are showing you the current registries that Podman is using, including a lot of other information. This is just another way to get your list of registries instead of fetching it from the registries.conf. Now I am going to do git clone. I think I do need sudo dnf install a git before I can do that. Let me do that. And then I'm going to use git clone. So git clone https://github.com/sandervanvugt/rhcsa. This is a directory with some supporting files that we are using in this class, including the container file and some more. Even including a resources.txt. I will update the resources.txt when you are working later today. In the resources.txt, I'm providing a list to upcoming live courses. So don't use it yet. Just refresh the Git repository later today and you get an updated list of related live courses that are going to happen pretty soon. I didn't update it yet, so give me a little bit of time. I'll tell you when it is ready. Getting in the rhcsa directory. Oops, I'm already there. And using Podman images. What is Podman images? Podman images is showing images that are available for the current user. I repeat, for the current user. In Podman, every user can run containers, and all of these users are doing their own stuff. You know, if your colleague is building a container image, that doesn't mean that you have access to it, and that is why everything you do with your containers is private. So if user Bob is using Podman run nginx, user Bob will fetch the nginx image and it will get in the user Bob home directory. If user Bill is also using Podman run nginx, user Bill will also fetch the Podman images. By default, all users have their own private environment. Now, the thing that really matters here is this container file. I'm using cat on container file, and what do we see? Let me put it on the top. We see a very minimal container file, which is using from registry access.redhat.com ub8 ub:\latest. This is the base image that I want to use. So I'm going to use the ub8 base image. UB colon latest, the colon latest, we call that a tag. And that is referring to the version of the image that you want to use. You want to use the latest version of the image. Then we have a run. A run is about commands that you want to run while building the image. So that is dnf install mmap minus y. That is going to install the mmap package. And then we have the CMD, and CMD is user bin nmap minus sn, and it's going to scan the local network. You will, by the way, see that it fills because in order to do an nmap network scan, you need root privileges, and I'm going to run it as a rootless container. I'm sorry, I've been too lazy to replace this mmap container file with another container file. That's not what I want to do here. I also don't want to talk about container files too much. What you need to know is how to build your own custom image based on a container file. So it's a Podman build process that's interesting. Podman build, Podman build, minus T, my map. Minus T is for tag, and the tag is really the name that you are going to assign to the image. So I'm using minus T, my map, and dot, where dot refers to the current directory. And that is a directory where it is going to look up this container file. And that's how it works. So Podman build always takes the directory that contains your container file as an argument. That's important to realize. So here we have step one, trying to pull registry.access.redhat.com, and it just did. 75 megabytes. Step two, it's running the DNF install. DNF happens to be a very inefficient package manager for containers. We don't care about it too much. Step three, it has added the CMD. This CMD is the default command that my container is going to execute. Now, if I use Podman images, then I can see that I have localhost / mymap, 265 megabytes, and we have the UB8 base image. And this is really what I don't like, because this UB image is 215 megabytes. That's not efficient. Compare it to Alpine or BusyBox, they are about 10 megabytes in size. And hey, you want it to be as efficient as possible. But the efficiency doesn't count here. What counts is that you know how to build a container image based on a container file. And next, you can use Podman run. How are we going to run this thing? Well, by using the fully qualified image name. And the fully qualified image name this time is localhost / mymap. You'll see that that it fills. I don't care that it fills. Couldn't open a raw socket operation, not permitted. That's because of nmap, what it wants to do, and the fact that it cannot do it without elevated privileges. That's not the thing that matters. What matters is that you know how to process a container file. And this is how you do it. In a minimal container file, and let me also have a look at that again, you have three components. From, for your base container, a run to run any command while building the container image. So a run is what you need to build your custom container image, and then we have CMD for the commands that you want to run. As you can see, the command itself is written in a weird way. This is not how we type commands on the command line, but in the container, it's common to specify your command in the array notation. And that means that every component of the command is between double quotes and comma separated from the next component. That's just the way it works, and you should do it likewise. All right, back on the slide where we can see our running containers. We have already seen that you can use Podman run to run a container. Podman run will search for the image in the configured registries, or even better, Podman run will fetch the image from the registry that you have used in the fully qualified container name. I should call that image name, by the way. Now, if it finds the container image, it will pull the image and run the container, and then you can use Podman PS to verify that the image currently is running. Podman PS is an important command, so let me show you Podman PS. All the container images that are currently running with their ID, with the name of the image, with the command, some information about when it was created, what the status is, and even an automatically generated name that you can use for management. Why would you want to do that? Well, you can use Podman Stop, for instance, and if you want to use Podman Stop, you probably want to use a name. So Jovial Hyped, I don't know how to pronounce it, that is going to stop it. And Podman PS, and now it's no longer there. If you use Podman PS minus A, you get an overview of all containers that have been used in the past. The thing is, when you run a container, the container image is fetched, and a directory is created on your local computer. And in this directory, a lot of stuff is created that relates to the container. If you stop the container, this stuff is still there. And that means that you can easily use Podman Start on Jovial Hyped, for instance. And that is going to start it again. And now Podman PS without the minus A is showing it as running. So you don't have to run it anymore if all the configuration is already present. How do we know? If you see Podman PS minus A, you see the thing that you need. Just use Podman Start instead of Podman Run. Now, if you don't need it anymore, then you can use Podman RM. What do you think? Is this going to work? Podman RM on Jovial Hyped. Do you see that tab completion is working? Of course it's not working because this thing is currently running. But Podman RM minus force should make it better. Hey, let's have a look at the anatomy of the command. We have Podman followed by the Podman instruction. In this case, the instruction is RM. Any argument to further specify the instruction should follow directly after the instruction. So it's Podman RM minus force. It's not Podman RM Jovial Hyped minus force, because in that case, the arguments that you put behind the name of the container are going to be interpreted by the main command that you run in your container. So make sure that Podman run arguments, Podman RM arguments, etc. are always behind the Podman run and the Podman RM. That's a common mistake. Now I've removed it, and removed it, that means that everything that ever existed on your system is now gone. Podman PS is no longer showing the Jovial Hyped, and that's okay because I don't like that name anyway. I don't know who or what it is, but I only know I can't pronounce it. What I also know is that by using Podman RM, the container, including all the files it has ever created, is removed. You might regret that. So think about using Podman RM. On the slide, we can see Podman PS minus A and Podman Inspect. Podman Inspect is kind of interesting as well. Let me do Podman Images. When I use Podman Inspect on localhost / mymap, for instance, I'm piping it through less, then I'm getting the entire container specification in JSON format. So I can see exactly what is in the configuration. I can see the environment variable. I can see the command that it is running, and I can see so much more. So if ever you are going to fetch an image and you don't know completely what this image is doing, maybe you want to do a Podman Inspect before. You can also do Podman Inspect on containers. Containers are running instances of the of the image. Well, in this case, it's not really a running instance, but let me use Podman Inspect on 742. And what is that? Well, I'm using enough of the container ID to uniquely identify it. So Podman Inspect 742 pipeless is giving me a runtime information about the environment that has been created by the container. Now, we all agree that currently it's not running, but even if it's not running, It has created an environment, and in that environment, you can see detailed instructions, like, for instance, the effective caps. That's about capabilities. That's a special kind of permission that is used by the container. Podman inspect is an interesting command to figure out what is going on. Now, on the next slide, we have some container commands. You've seen many of them already. So Podman run is what you use by default. If you use Podman run, the container runs its default command. If you can also run an alternative command, and if you want to do so, you specify it as a command line argument. Like, for instance, Podman run docker.io slash library slash nginx. Oops, I wanted to make that Podman run minus IT. The minus IT arguments are going to open an interactive terminal, and I'm using sh to open a shell. What did I do now? I started the nginx container image, but I have overwritten the default command. Instead of the default command, I'm now using a shell. And if I'm lucky and this container image contains the ps command, which is not guaranteed, then I'm going to see all processes that are currently running. And as you can see, unfortunately, the docker.io library nginx does not contain the ps command. And in case you think that is surprising, well, it absolutely is not. Because a container, all that a container is about is running your applications. So what should you have in a container image that is efficient? You should only have the application itself and all its configuration and dependencies and nothing else. And the ps command, yeah, that happens to be a package that is normally expected on an operating system. But why would you want to have the ps command in a container? A container is about running an application. A container is not a virtual machine. TL, the difference between Podman Run IT and Podman Run exec is that both of them are not working. Your command line syntax is wrong. Please use correct command line syntax. I think you want to know what is the difference between Podman Run and Podman exec. I will answer that question later, but if I'm misinterpreting what you want to know, please follow up by asking this question again. A little bit of a geek detail: if PSAUX is not working and you really want to know what is going on, there's a geek way of finding out. Use ls on /proc. /proc contains PID directories for PID1 and PID2. PID1 is the entry point application in the container. That's the default application that has been started. And if you really want to know, and again, this will never be on RHCSA, but it's cool to know, and that's why I'm showing you. Use cat proc1 cmd line, and there you can see the command line behind PID1 inside this container is sh, and sh is the shell. Hey, what did we just do? And here we come to what I think is an answer to your question. I use this nginx container image to overwrite the default command. That's what I'm doing. I'm overwriting the default command. PID1 is a shell. There is no nginx started in this nginx container. I've overwritten it. Why would you want to do that? For analyzing and troubleshooting. Now I'm going to exit. By the way, if I'm typing exit, I'm sending the exit to my shell. So it will close the shell and I'm back in my environment, and Podman PS is no longer showing the container as running. Now, TL, what is probably the second part of the answer to your question, I'm going to use Podman run minus d nginx. I want to start the nginx container in the background mode. And now I'm going to use Podman exec minus IT 6f1. I'm using enough of the UI of the ID of the container to get in, and I'm using sh. So again, I'm opening a shell in my nginx container. We already know that I don't have a ps command, but this time if I use ls on /proc, what do I see? I see multiple PID directories. PID1, PID24, PID25, PID26, PID27. And if I use cat on /proc/1/cmd line, then I see this is the Nginx master process. So I started the container using podman run -d, so it does start the default command. And I've used podman exec to run an additional command. And this additional command is the shell. It all depends on what you want to do on your container, but these are two different ways to get into your container. Also, another interesting fact, when I used exit right here, when I used exit at the moment that PID1 was my shell, it stopped the container. Now I'm going to use exit as well, and I'm using podman ps, and we can see the container is still here. Why is the container still here? Well, I only exited the shell, probably that was PID26, but by exiting the shell, I did not exit the primary process. So TL, I hope that is answering your question. Let's continue on the slide. Yeah, we already know if you want to run an image from a specific registry, you specify the complete image name, and command line options need to be specified before the name of the image. Let me show you something that is wrong. Podman run docker.io/library/nginx -itsh is giving me an error message. What is the error message? Well, the error message is telling me docker entry point.sh -it not found. Why is that? The -it is interpreted as an argument for the primary command that the container is running. And this primary command is docker entry point.sh. It's a script that normally would start the Nginx web server. And it's complaining, yeah, not found. Yeah, that makes sense because my my -it is in the wrong position. It needs to be behind the Docker run. Did I say Docker run? Shame on me. Of course, I meant podman run. Now another demo about running containers. That would be podman search UBI. We haven't seen podman search before. I think you understand what podman search is doing. And hopefully the result that you see here does help. So I can see all my locations of UBI. I am going to use podman run --name sleepy docker.io/redhat /UBI9 sleep. So what am I doing? I'm overwriting the default command in this UBI9 and I'm replacing it with the command sleep 3600. So this is going to sleep for an hour. And we can see it's pulling the image. And in case you are surprised to find the UBI9 container image on Docker, yeah, that's what they do. Red Hat makes sure that most of their public container images are also on Docker. They don't want you to use Docker, but they want Docker users to find these awesome Red Hat container images. Now, what is happening right here? My UBI9 is sleeping for an hour. That's not very convenient, so I'm going to open another terminal, and in the other terminal, I'm using podman ps. And podman ps is showing my sleepy container. I'm going to use podman stop sleepy, and that will stop it. For your information, there's also podman kill. Podman stop will friendly ask, and if it doesn't work within 10 seconds, it will automatically use podman kill. Which means that unless you are in a hurry, you never use podman kill. Podman kill doesn't add anything because podman stop, as you can see right here, is killing it automatically. Getting back to my main console and using podman images, and there we can see the UBI9 image from Docker is available as well. And now I'm going to do what? Well, I don't want it to run in the foreground, so I'm using podman run -d --name sleepy docker.io/redhat /UBI9 uh, sleep 3600. And oh boy, what is it telling me? It's telling me that I'm doing something wrong. The container name Sleepy is already in use by blah blah blah. I can do two things. If I really want to use Popman Run, I can use Popman RM Sleepy. I can also use a smart solution and use Popman Start Sleepy to start it. But here I want to remove it, so Popman RM on Sleepy, and now it is gone. Podman PS minus A, and we don't have the sleepy container in any way anymore. It has been removed. And that's what I wanted to show you here. Now about troubleshooting. If you are troubleshooting containers, often it comes down to troubleshooting the primary command. Now you should notice that some containers run to completion and there's nothing really to troubleshoot if you don't see them. And if you want to troubleshoot and further investigate, you might want to use Popman Inspect on your container to see which command is started as the primary command. You can also use Popman Run -IT to get more details about what it is doing. And a very important one for troubleshooting is Popman Logs. Before doing anything else, let me do a quick demo. I am using Popman Run BusyBox. I also wanted to show you this. It has found, it has resolved BusyBox as an alias. So it has found BusyBox in docker.io. And even if I did not use a fully qualified image name, it has fetched BusyBox from docker.io. Popman PS, what do we see? Well, I see no BusyBox. Popman PS -A, I do see BusyBox right here. And you probably want to know what is going on. Well, what is going on is that BusyBox was created 17 seconds ago and it exited, and the most important thing is the zero behind it 17 seconds ago as well. You know what's going on with this BusyBox container? BusyBox is one of these generic container images, and generic container images are starting a shell. But if you start a container that runs a shell and nothing else, the container will come up and immediately go down because the shell doesn't like to be just a shell. The shell needs some work to do. And at least it needs to be connected to a standard output. As a container, it is not. And that is why its expected behavior of these generic container images to come up and immediately go down again. And that's why we see this exited of 0. Now, if I do another one, Popman run docker.io/library/MariaDB, we should see different behavior. And in case you are wondering, why are you always using docker.io? Because the image names are easier. And I don't care about using Docker search. And don't worry about the exam. They will tell you exactly which image you are going to need. So what do we see here? We see that MariaDB is coming up. And of course, I can read the outputs to already check what is going on. But it's not always that obvious. So let's just go the normal way. Popman PS. Oh no, I have no MariaDB. Popman PS -A. And what do we see? We see created and exited 22 seconds ago. But now we see exit 1. Exit code 1, or better, exit code anything that is not a 0, means that the problem has that the application has experienced a problem. And we need to investigate what is going on. Now, to investigate what is going on, you are going to use Popman Logs. So Popman Logs on Vigorous Dijkstra, and there we can see the standard application output, where it is telling me that we need one of the following: MariaDB root password or blah blah blah. So instead, I should have used Popman. I'm going to pick it from history. Popman run docker blah blah minus env. I'm sometimes mixing up Kubernetes parameters with Popman parameters, but hey, I'm going to give it a try. MariaDB root password is password. Then it was -e anyway. I wasn't too sure about it. Oh no, I'm doing something stupid. I'm not thinking properly. Hey, I did this unintentional, but it's a good error. What is the error here? Well, I'm using my minus e and minus minus env behind the name of the image. That's not what we need. We need minus minus env, MariaDB root password is password. And there we can see that it is all working. Yeah, before the name of the image. That's what is going on. About SQL, MariaDB accepts MariaDB root password as well as my SQL root password. I really think it is weird to create MariaDB with a MySQL root password. That's why I defaulted for MariaDB root password. It really depends on the maker of the image. But the real problem was it needs to be before the name of the image. Stopping it, and now it should be gone because I also didn't have a minus D in front of it to run it in detached mode. Okay, environment variables. That's what we have seen. Minus E key is value. Aha, nice to know that minus E and minus minus E and V are both okay. I'm not going to do this demo anymore because this is the demo that I just did. Without the interesting error. Yeah, and there's Scopio inspect. What is so special about Scopio inspect? Well, Podman inspect can inspect images that you have fetched to your system. Scopio inspect can inspect images when they are still on the image registry. Is that important? It's not extremely important. It's a fun command to learn about. So here you go, Scopio inspect. I don't think it's important enough to run it separately. So short before the coffee break, we should do more important stuff like configuring application access. Let me ask you a question. When you are running an SSH server, how are you going to access the SSH server? Well, the generic answer is the SSH server binds to theoretically a TCP or UDP port. In practice, it's UDP most of the times, but in theory, it can also be. Did I say UDP most of the times? That was wrong. It's TCP most of the times. In theory, it can also be UDP. For containers, that is not any different. But if you want a container to connect to a port, you need to tell your container. It's not like HTTPD and stuff like that. These are all services that have their default port. You start them with elevated privileges, and that allows the service to bind to the default port. That doesn't work for containers, and particularly not for rootless containers. So in order to provide access to the rootless container, you need to provide a port mapping. So that makes that the port on the container host is exposed and forwards traffic to the container port. And port mappings can be set while starting the container. You cannot set them on a container that has already been started. So if you just started the container and you forgot to put a port mapping in there, then I'm sorry, you need to stop it and start it again with the appropriate port mapping. And in case you are wondering, does the IP address play a role in this? Well, I have a surprise for you. Rootless containers do not have an IP address. And in case that is shocking for you, because in Docker every container does have an IP address, I have one thing to say. Why would a container need an IP address? I mean, a container is just a fancy way to run an application or a service. If you run an SSH server or an HTTPD server, you also don't give it an IP address, right? You are going to bind to an IP address on the host. That's exactly what we are going to do with the container, but in this case using a port mapping. Do keep in mind that rootless containers can only map to a non-privileged port. So quick demo. Podman run. minus D minus P. Minus P is for the port mapping, 8080. Oh yeah, I wanted to show you that the privilege port doesn't work. So 80 colon 80 docker.io slash library slash nginx. And there we get the error message, and the error message is, dude, you are running a rootless container. This is not going to work. How are we going to do it? By using minus P 8080. And the minus P 8080 is going to expose port 8080. Use popman port minus A, and there we can see that the port 80 TCP, that's a container port, is on host all IP addresses 8080. You can also use popman PS to figure out the port mapping. Here you can see the port mapping as well. I think this port mapping, the way it's written here, is a little bit easier to understand, because really about incoming traffic to host port 8080 will be redirected to port 80. So if I use curl to localhost colon 8080, I am getting, thank you for using nginx. Yeah, there's an nginx working there. Also, just because it's fun, I wanted to show you sudo firewall cmd minus minus add port is 8080 slash TCP minus minus permanent. I mean, if it needs to be accessible from the outside, you also want to put it in the firewall. And next sudo firewall cmd minus minus reload. I can hear some of you guys thinking, oh no, Sander, you didn't tell us about add port yesterday. How am I supposed to figure this out on the exam? That's a fair question. You use firewall cmd minus minus help, where you can see lots of command line options. Minus minus help pipe grab port, which is showing, oh, that's still a lot of options, but add port, and this is the add port. So add port is port ID optionally arranged slash protocol, and hopefully based on this help you will be okay. And B is asking, so rootless containers have to have unique port numbers. I'll make it even stronger, MB. Every container needs a unique port number. If you are going to try to use a non-unique port number, then you get a complaint that the port number that you are trying to use is already in use. But what you probably mean, MB, is you probably expect an nginx container to be exposed on port 80. That is not happening because it's a root port, and because there can only be one process listening on port 80. So if you have multiple web server containers that all want to run on your host, and that's a real question here, you need to give all of them a unique port number. That is not for rootless containers. That is for every container, because you can use a port number once only. Firewall CTL minus minus panic on. Oh, sorry. Firewall CMD minus minus panic on. It's funny, I was seeing what you typed and I thought, hey, that sounds so weird, but I didn't immediately recognize it. What is this panic on, GC? Honestly, that's an option that I've never seen before. I'm trying to run it. I don't see any action. Probably it's giving feedback if it doesn't work. Oh, you saw that option, and that sounded very funny. Honestly, I have no idea what it is. I do know that it's not really relevant. So if you don't mind, even if you make me curious, I am going to continue and do this firewall CMD minus minus reload. I should have put sudo in front of that. What is next? Next is managing storage. This is the part where it's really becoming serious. Everything we have seen so far is part of the introduction to containers. Now we are getting to the hard parts of containers. And before I'm going to do that, I want to do another break. So here is command history. And let me open. Yeah, that's what I was expecting, MD. Let me open and let me run the countdown timer. Uh, what MD is saying, firewall panic mode is a mode that stops all traffic, and that's what you use if you have a serious problem. You're absolutely right there, MD. And oh boy, did I just mess up my firewall? Well, fortunately, I use firewall CMD minus minus reload. But based on what MD is saying, I want sudo firewall CMD minus minus list all just to verify that we still are okay. So because of the reload, my panic mode seems to be off. So no panic, but coffee. Starting my terminal with the countdown timer. You know how it works. Talk to you in a bit. Hi, folks, I'm back. And B, I'm not sure what you mean. Is it Wild West when it comes to commands between Kubernetes, Podman, Docker? There are different developments. Podman was developed to be completely Kubernetes, completely Docker compatible. Kubernetes is about running containers in serverless computing environments in cloud. You have different needs, you have different resources. Kubernetes is a different beast, so I wouldn't say it's Wild West. It's a different solution, and a different solution comes with different commands. Let's talk storage. Yeah, kubectl, I get it. Interpret my answer MB as addressing kubectl. Now, what's the problem with storage in containers? Well, the problem is that container storage is ephemeral by nature. Ephemeral means short living, and that means that nothing is done to guarantee the persistency of anything that is created in a container. That's not cool, so you need to do something about it. And what are you doing about it? Well, in a standalone container environment, the default solution is to do bind mounting. So you mount directly on the host in the container. And by doing so, you make sure that everything you write to the bind mounted directory will be written to the host directory as well. This bind mounting is what you do using the -v option. So -v slash host dir colon container dir. But there's a challenge. If you are going to do that, first, the user that is used inside the container needs to own the directory on the host. Just imagine that you are running a rootless container as user student, and you are trying to bind mount to the /var/log directory. Do you really think that your container is going to be allowed to write files? Of course not. We need to take care of permissions to start with. Now, the easy solution, and that's a solution that we focus on for our HCSA, is that when you run a rootless container, you bind mount to a directory in the current user home directory. Then the topic of ownership is no longer a topic. In some cases, you will need to go deeper and inspect and find out which user it really is. And you can even use Podman unshare to make that user owner. More about Podman unshare. What is Podman unshare about? Well, the thing is that we get something difficult here. So let me try to explain. The thing is that rootless containers are launched in a namespace. What is a namespace? A namespace is an isolated environment where nothing else is seen. It's for security reasons. And this namespace provides isolation, and that allows the container inside the namespace to have a root access to whatever the container is doing. So the container itself can do whatever it wants in its own environment, unrestricted access from within this isolated environment. But once we get out of the container environment, this level of isolation no longer exists. Now, when you use containers, UIDs that are used inside the container namespace are mapped to UIDs on the host, and these are dynamically created. And the Podman unshare command can be used to run commands inside the container namespace. And we just need to do that. Let me see where we are going to do it. Yeah, next slides. 2 more slides. I know this is not going to be completely clear until I finish the second slide that is coming right now. So please bear with me. We'll get there. So to set appropriate directory ownership on bind-mounted directories for rootless containers, additional work is required. What is going on here? Well, what is going on? And that's also the example that we are going to use. You are going to run a MySQL container. MySQL or MariaDB comes with its own user ID. How are you going to make sure that this MariaDB user ID has permissions to the directory that you are going to bind mount? And in case you are wondering, do we need to bind mount? And of course you do, because if you are going to run a database container, you want to be able to store the database somewhere, right? Now, how is this going to work? Well, you first need to find the UID of the user that runs the main application. In the case of MariaDB, that would be the MariaDB user or the MySQL user. UID 27 is the default user ID for that container. And a common way to find that user ID is by using podman inspect on the container image. Excuse me. In the container image, you normally find a user parameter, and this user is defining what you are doing. If that doesn't work, which is pretty rare, you can also use podman exec container name and catch your etc pass WD or grab your username etc pass WD. Because you need a UID, you do not need a user name. And I'll tell you in just a little bit why that is the case. You need a UID, not the username. So UID 27, not MySQL. Now, once you have found this user ID, you are going to use podman unshare chown nn nn on the directory name that you are going to bind mount. And that will set the container user ID as the owner of the directory on the host. So podman unshare chown 27 27 on directory name. Hey, let me show you what's going on. I'm making a directory. Let me not do that in the RHCSA subdirectory, but let me make a directory data. Let me use podman unshare chown 27 27 on data. And let me use ls minus L on data. For MySQL, I'm specifically talking about MySQL. 27 is not the default for all containers, it's only for MySQL. And I'm preparing you for the MySQL example. Different container, different user ID. You need to figure out which user ID it is. Now, when I use ls minus L data, what do I see? I see a user ID of 100,026. What happened to my user 27? Well, I use podman unshare, and podman unshare is working inside the namespace. And the namespace is the isolated environment that is used by the container. If you really want to see what's going on inside the namespace, you need podman unshare command. So podman unshare ls minus ld on data, and that is showing 27 and 27. So when the container is going to run, this container is going to use user ID 27, and within the namespace that works. But outside of the namespace, we still have the directory. So what are we going to do with ownership of that directory? Generically in the host operating system, that is where the user mapping is used. All these private user IDs, like 27 for the container, need to correspond to something generic on the host operating system. And the something generic is private UID plus 100,000 minus 1. And that's where this 100,026 is coming from. For now, 0827 is a random example. What counts is that you understand these user IDs, and that the user ID in a container namespace is not the same as the user ID outside of the namespace. Now also notice that if you are going to provide access to this bind-mounted directory, this bind-mounted directory for a non-root user needs to be in the user home directory, because otherwise it would be in a different namespace. And if ever you want to find these mappings, you can use podman unshare cat /proc /self /UID map. And this proc self UID map, that is where the mappings are defined. And the mapping between these user IDs, that is dynamic. Let me show you podman images. I need MariaDB. I'm using Podman inspect of F35. It's enough to uniquely identify the MariaDB image using less, and I am looking for, where is it? Oops, I just saw it. I'm looking for user. Where is this user? Might have to figure out the running instance of the container. Podman PS is showing me Nginx, Podman PS minus A. I need this MariaDB, and let me do a Podman inspect of E8F by Bless. And there I'm looking, where is it? The user. User. This is difficult to find, but hey, let's look it up. User. I don't see my user definition in MariaDB. This is not a good example. Please forget about this example, this failing attempt to look up the MariaDB user ID. Let me just continue, because by continuing, we will make it better. And that's what I'm going to do right now. Yeah, I know what was going on. I will finish this demo. I think this demo is going to explain a lot of this part that is quite difficult. I was inspecting the wrong image and then it doesn't work. So I'm going to do the demo the way it's written on the slide. You know, the thing is that all these container images have been configured differently, and I was just looking in the wrong image. So let me do a Podman search, and that's a good idea as well, GC. Podman search, MariaDB, grab Quay. What am I trying to do here? I'm trying to search in Quay.io. Why does this not work? Oh boy, oh boy. I'm making a mess here. I'm trying to search for an image on Quay.io, but Quay.io is not in my registry.conf. Right. Then I'm just going to run it and skip the Podman search, and I will run Podman run. Minus D, minus name, my DB, minus E, my SQL root password is password of Quay.io slash CentOS7 slash MariaDB 103 CentOS 7. Get out of here. Error initializing. Now I'm getting slightly frustrated. Look up Quay.io on 53 UDP write operation not permitted. That seems like a DNS related error. 192.168.29.11. That's a virtual machine trying to access this 192.168.29.2. Oh my goodness. Can we ping it? And Quay.io name or service not known. Okay. Sudo nmty. I'm expecting something to be wrong with my network configuration. I don't want to troubleshoot networking here. Yeah, that's a good one, MB. Did we ever get out of the firewall panic? I don't want to analyze, I'm just going to reboot it. Then we should get out of the firewall panic. I used firewall CMD minus minus list all that looked as if we are fully in business. But MB, you are totally right. It looks as if either there's a network problem or there's a firewalling problem. And in the context of this firewall panic, oh boy, this is the last time that I'm going to try this fun option that somebody is telling about. But this firewall panic might bite me here. I did not ever make it persistent, and that is why I'm going for the lazy man's option, and I'm giving it a quick reboot. A reboot is often faster than real troubleshooting. This is also what I would recommend on the exam. You get a situation like this on the exam, don't start troubleshooting. Ping on quay.io. Are we doing any better? Well, at least it finds the IP address. That is looking good. Okay, now I dare giving it another chance. There we go, and now it's working better. I'm pretty sure it was indeed the firewall panic. That was fun. Right. So back to where we were. I'm running my database here. I'm doing a Podman PS, and in Podman PS I can see this database thing up and running. And now finally Podman inspect on my DB. And Podman inspect on my DB is showing me, well, should show me the user ID. User, there we go. This is what we were looking for. Finally, we're here. User 27. And this user 27, that's this database user. Now it happens to be that MariaDB by default uses user ID 27, same for MySQL. Don't know why, but it might come in handy to just know it. And if you don't know it, run the container, find the user ID that it is using by doing a Podman inspect on the container. Next, Podman exec, MyDB, grab MySQL, etc, pass WD. So this thing is running a MySQL user ID 27, and this user 27 as a home directory that is set to varlib MySQL. Why is this varlib MySQL interesting? Well, because if we are going to start this MariaDB thing, if you want to create a database, then this database will be written to varlib MySQL. So varlib MySQL in the container needs to be writable. How are we going to do that? By using mkdir on MyDB first, and then by using this podman unshare shown 27:27 on MyDB. Again, ls-ld on MyDB is showing us what we have seen before. User ID 27 with the user that is represented on the host operating system. If you are interested in the background information, podman unshare cat /proc/self/uid_map. What do we see in the UID map? We see the UID mappings. And in the UID mapping, what do we see? Well, we see that we have a mapping of user 0 to UID 1000, and user 1 is adding 100,000 on top of it, and brings it all the way up to 65536. MB is asking if both MySQL and MariaDB can use MyDB slash. So far, yes. So far, MyDB has only been configured with the user ID setting. Right, what else do I want to do? I want to do my podman unshare. That's something that we have already done. Podman unshare ls -ls minus LD on my DB, and that is showing the user IDs from the perspective of the container. So if we are going to run the container sees user ID 27. Now, this brings us to the part where we have set the ownership. But there's another nasty beast that we need to work with, and that is SE Linux. Because in SE Linux, you need to make sure that the container is allowed to access this directory. And the fun thing is, if you don't do SE Linux, it is not going to work. GC is mentioning, so containers work with a specific user. GC, let me phrase it differently, containers may work with a specific user. That depends on how the container is configured. Where MySQL is a nice example, which is using this user ID 27. You thought they work internally with a root user. That may also be the case. A specific user will let us know who to grant permissions and the work path. It's a specific user that requires this UID mapping. And the root user, in fact, makes it a little bit easier. You don't have to do anything if you work with the root user. So it's the specific user case that we need to worry about. Now we need to worry about SE Linux. Now have a look at the slide, because in order to mount a host directory in the container file T SE Linux context type must be used. And that's not the case. Now the interesting thing is that if the ownership on the host directory has been configured all right, you can automatically set it. And you use uppercase Z to automatically set the context that you are using. Like podman run -v, and then we have the string. So in this case, that would be home student mydb maps to varlib mysql with the uppercase Z option. And the uppercase Z option, that makes that it is doing all right. Now, that's what I'm going to demonstrate. TL, be specific. I don't know what you want to do here. GC is asking, how should I know? How should I know? That relates to the user. Well, that is by running the container, doing a podman inspect, and check out the user that the container is using. If you don't have a user, then it internally will work as root. If you do have a user, then it's a specific user ID that you are looking at. Okay, TL, I see the question that you originally asked. TL was asking if root, it is a rootless container and is requested to bind mount to a directory different from the user's home directory. Can we change ownership to make the user owner of the directory? Yes, TL, you can. Right, let's continue and let's wrap up this bind mounting in combination with SE Linux. So where are we? We are at the slide. The slide is demo. So this demo continues on the podman unshare part, where we have taken care of the user ownership. Now we need to take care of the SE Linux part. How are we going to do that? Well, we are going to stop the container. Podman stop mydb. I am going to remove the container, podman rm mydb, and now I'm going to repeat my podman run command. Where is it? There it is. So podman run -d -name mydb -e for the environment variable. And then we need to take care of the bind mount. We never did the bind mount so far. So -v /home /student /mydb /var/lib /mysql uppercase Z. And we keep the rest of it. If you do a bind mount, do yourself a favor, make it always an absolute path name. Relative path names will most likely fail depending on how you are going to run the container. They will cause problems later. So make sure that in your configuration of the container, and this is written to the configuration of the container, you have an absolute path name. That's what we just did. I'm going to use ls minus z on my DB. And what do we see? We see that within my DB, a directory has been created and a file has been created. And we see the SE Linux container context, container underscore file underscore t. And that makes that it is working out all right. TL wants to know if it is possible that the container bind mounts to two different paths. Yes, then you need minus V 2 times. Same rules apply. You need to take care of ownership. You need to take care of SE Linux. All right. This was the stuff about accessing files, about bind mounting. And this bind mounting definitely has not become easier by using rootless containers, but for sure it has become more secure. Why is it so important to make this more secure? Well, if you are on a Docker stack, on Docker, where your containers are running with elevated privileges, you bind mount the root directory of the host file system within the container. You have full access to the entire root directory. That's something that I'm going to work out next week on Friday when I teach my containers in 4 hours class. For now, we need to move on to the next topic, which is auto-starting containers. Yeah, what is going on? Well, to automatically start containers in a standalone situation, you can create systemd user unit files, and you can manage them using systemctl. The idea behind all of this is that a container, in the end, is just a command. So you are going to run a command, and you are going to put that command in a systemd unit file. And once you have the systemd unit file, you can manage that as the ordinary user. So I'm going to introduce the systemd user unit file. And that's what we need to automatically start it. If you are using Kubernetes or OpenShift, auto start is happening automatically. There's nothing to worry about. But for standalone containers, this is important. GC is asking, so as soon as you add this minus uppercase Z, is it added in the SE manage F context? And if you run a restore con, yes, it will still have container file T. And TL is asking for root containers, the process is the same, or is there differences? Well, if you are a root container, then you start a process as a root, and the issue of access doesn't really play because you are running an insecure container. But fortunately, for a root container, there is still the SE Linux. So for SE Linux in a root container, you still need this uppercase Z. I don't think you ever need to run a root containers. Let that be your starting point. I want to talk about running systemd services as a user. That's a generic thing that you can do in systemd. Any user can create a systemd unit file and start any command that the user wants to run. So systemd user services is what we call them. And these user services start by default when a user session is opened, and they close by default when the user session is stopped. Now, if you want to automatically start a container, that's a problem. Because if you automatically start a container, you want the container to be started when your system starts and not when the user logs in. So we need something in addition. And that's a systemd setting that you accomplish through loginctl enable linger. That's a setting that you set for your users. And if you have that setting, then user services can automatically start it for a specific user without that user logging in. And that's what we want, because otherwise it doesn't really make sense. So if you want user Linda to automatically start a container, login CTL enable linger Linda. You can verify that using login CTL show user, and if you really want to, you can disable it using login CTL disable linger. Now, how are we going to bring this to systemd services? Well, you create a regular user account to manage all the containers. That's one option. You can also have your containers for specific users. You can use Podman to generate a user systemd file for an existing container. And that's the challenge. If you want to automatically start a container, how are you ever going to write the systemd unit file the right way? Well, you use Podman to generate the systemd unit file. Before you do so, and this is an important one, you need to make sure that you have the appropriate config directory. That's in .config/systemd/user. You activate that directory, and then you are going to do your things. This is very important. Don't forget it, because if you forget this essential step, the user file will be in the wrong environment, and it won't work. So once you are in this directory, you can use Podman generate systemd to generate. So Podman generate systemd, that will generate a unit file. Minus minus name, that is the name that you want to work with, the container you want to work with. Minus minus files, minus minus new is making sure that you build up everything the right way. You can do that for rootless containers. You can also do it for root containers. The only difference is that a root container unit file should be an etc systemd system. There's an awesome man page for Podman generate systemd. Check it out. It might be helpful on the exam. If you have a hard time remembering all of these conditions, read the man page. It's definitely going to be helpful. Now, what is behind Podman generate minus minus new? Well, this option will create a new container when the systemd unit is started and delete that container when the unit is stopped. So you should really think about the minus minus new option. Because you are disconnecting, it will delete your container. And do you really want a container to be deleted? Well, that will really depend. In some cases, that will be terrible if you delete your container, because you will lose lots of the parts of configurations that are written to the ephemeral storage. So this option minus minus new really depends on what you want to do. So yeah, without minus minus new, I just told you it's not created new and stopped. Now, Podman generates, that is what you are going to use, and you manage your user files using systemctl minus minus user. Like systemctl minus minus user daemon reload, which will pick up the configuration. Systemctl minus minus user enable myapp.service. Which really needs your user to have these linger privileges. And systemctl minus minus user start myapp.service, which is going to start the container here and now. Do notice that if you just generated a systemd unit file to start your container and your container is still running, this is most likely going to fail. Now, one other thing that's pretty important is that the systemctl minus minus user commands only work when you are logging in on console or SSH. They do not work if you are in a sudo or su session. That's pretty important. Because I know what you are doing, but I always use su minus to open a shell as the target user. Well, that trick is not going to work in this situation. What I like to do for this specific scenario is login, SSH user at localhost. I'm opening an SSH session because an SSH session is a real login session. And in an SU session, you always have some information about the previous user still roaming around. Now here we have the procedure that matters, the procedure that brings everything together. Let me run this procedure. I'm not going to create user Linda. let me cat on, or let me grab Linda on etc password. We already have user Linda. Next, I'm going to use sudo login ctl, enable linger Linda. And I'm going to use SSH Linda at localhost. Oh boy, is that explainable? Yes. Sudo vim etc sshd underscore config. You remember yesterday we configured SSH to listen on port 2022. I want it back on the original port. Sudo systemctl restart sshd. Second try. This is working better. Logging in as user Linda. Right, next I'm using mkdir-p.config slash systemd slash user. And I'm using cd.config slash systemd slash user to make that my active directory. And now I'm going to run podman run -d minus name my nginx -p 8081 colon 80 on nginx. Will that work? Oh, it's going to ask which nginx. I'm okay with the which nginx. I'm using docker.io and that will do it. So what do we get here? We get an nginx process that is running and that should be accessible on port 8081. And in case you are wondering, why don't you use 8080? Well, we have used 8080 for a previous container, so that should be already in use. Can't use the same port twice. Next, podman ps, and podman ps is showing the running container. Next, pwd, just to verify that I'm indeed inside the .config slash systemd slash user directory. And I'm going to use podman generate systemd minus name my nginx minus files minus new. And again, if you do this on the exam, read really careful if you do or don't need this option minus new. Let's have a look at this container my nginx service. What do we see? We see that we have an exec start, and the exec start is starting my containers. It's really a podman run command with some options that I don't want to explain here. Really, we don't care about them. Podman run. This is a fancy podman run command that basically has put the command that I just used in a systemd unit file. Then we have the exec stop, and here you can also see what the new is doing. It's doing a podman rm-f to stop to remove the container. I repeat, that is not something that you might want to do in all cases. So be very careful about it. So next, I'm using systemctl --user daemon reload. I want to make sure that the process has been picked up and the user environment is aware of it. Next, I'm using systemctl --user enable container dash my nginx dot service, and that is going to enable it. And now I'm going to reboot. And why am I going to reboot? Well, I need to make sure that the container is started after a reboot. And the only way to verify is by doing the reboot. That won't work as user Linda. So let me exit and use my sudo reboot here. And then once it is back, we'll troubleshoot. I've seen the question, how do we troubleshoot? But I want to stay concentrated on what we are doing here. And I want to complete this procedure and not open a sidetrack. So let me first do this. Open once again the terminal. What I'm going to do here is ps faux pipeless, looking for processes that are owned by user Linda. And what do we see? We see the system the user, and we see as a child in there this process with all the parameters. Conmon, that's a container monitor. So that's your container. And as conmon container monitor has started Nginx, but just the fact that this Linda process has been started without user Linda logging in is sufficient proof that it works. Surviving all the challenges. As you have noticed, what we've done this hour was not the easiest stuff. So let me give you a couple of hints that hopefully are useful. Challenge number one: if you are going to do this systemd container auto start, you log in as a user that should start a container. Do not use su minus. Obviously, the user needs a password to do so. As that user, mkdir-p dot config systemd user change into that directory, and from there you are using podman generate. When I created these slides, I wasn't critical enough about the minus minus new. I'm not sure you want to use minus minus new by default. Better focus on a man page, podman generate systemd. And these are the important things. Now, if you are ready for the real challenge, then this lab is what you are going to do. I'm not going to do this lab in this class because I'm afraid we won't have time for anything else. This lab comes from the recorded video course. You will find the solution to this lab in the recorded video course. But if you think I'm ready for the exam, make this lab, verify your work. If you're good, then you are ready for the exam. If you don't know how to run the procedure in this lab, don't go to the exam. Couple of questions. So TL is asking, how can we troubleshoot if we made the steps to bind mount? The image is running all right, but we don't see contents of the host directory that we mounted. Then your image is running all right, and you don't see contents. Well, the only thing I can say is that you have bind mounted the wrong directory and the content is written somewhere else. So you need to check out what the main application is doing. I don't have a generic way of troubleshooting. That depends on the main application. For MariaDB, in my process, I've shown you the MySQL user in etc passwd. I've shown you the home directory of the user. The home directory of the user that runs the primary application, that is often where the files are written. That needs to be bind mounted. I would look in there. SJ is asking if the exam question does not matter whether container must be removed or not after reboot. Yeah, that's something to be aware of and important. And JS, you are overwhelmed. That is normal. Yeah, that's the only thing I've got to say about it. It's like SC Linux. People are also overwhelmed that when they hear about SC Linux. Let me share my experience, SC Linux, knowing that this experience is the same. First time I heard Dan Walsh explaining SC Linux on Red Hat Summit, I felt like I wanted to cry. I was lost after 10 minutes. But then I read about it, I studied it again, and I practiced, and that really worked. In order to really master technology like this, you need to do it at least 3 times. And B, you will find the video for the lab in the course resources. And everybody, I'll tell you where the course resources are in a second. I want you to work on the sample exam. I'm not going to give you a break. I want you to decide for yourself if you need a break or not. Let me explain how it works. In the course Git repository, I'm getting back, oops, I'm doing the wrong thing. I'm getting back to the course Git repository. We are going to do some hands-on now. So sudo minus I and history pipe grab git. I don't have it. Okay, not sure where it is. Git clone https. I'm typing it in the group chat so that you can easily copy paste it. Github.com slash Sanne van Vught slash RHCSA. That's the course Git repository. And in that course Git repository, which was in the student environment, there we go. In the course Git repository, you'll find the mini exam 30 minutes.txt. Open that file. It contains a mini exam. It's a mini exam. I've created this mini exam for you to do in 30 minutes. Half past the hour, I will start explaining what is in the mini exam. So your time has started already. If you think you need it all, don't hesitate to get started. But this mini exam is created to run in your current environment. So don't start by installing a new virtual machine. That is not needed. And be a little bit flexible. If you don't have the exact sizes, I am not going to tell you you failed because you didn't have 500 megabyte and you created a 400 megabyte partition. It's the idea that matters. This mini exam is what I want you to do right now. After the break, I will have updated resources txt, and I will tell you about the resources txt, and that MB is where you will find the video for the lab that I just mentioned. But I want to make sure that it is up to date and also all relevant upcoming courses are in there. So that means that, yeah, I can type history. Do I want to type history? Why not? Here is my history. And I'm going to open a new window and I want you to work. How will it work? Well, my break timer is set to 25 minutes. That's the time remaining. I'm going to have a nice cup of coffee. You are going to work. I have no further comment on the questions. It's like the real exam. The questions are as is. On the real exam, if you see a question that is surprising, you will also get no help. And I want you to live the experience as similar as possible to the real exam. So you are going to work for yourself. No need to send in your solutions. Just verify your own solutions by the time we get back. That is half past the hour. And I will show you solutions. You can verify your work and you will know whether or not you are ready. We will have some time for Q&A once I'm back. And then this class is over. As I want to consider the remaining time as real exam time, I'm going to close my microphone now and I'm going to tell you good luck. I will be back in 1440 seconds. Talk to you in a bit. Hey folks, I hope you had a lot of fun and we are running out of time. Yay! Let me stop the countdown timer. Now, first, I would like to know, did you finish? I'm going to send this poll question and send me thumbs up if you finished and thumbs down if not. Regardless, I'm going to tell you about solutions for this sample exam. So, while going over it, hopefully some tips and trips that are going to help you. But first, the mini exam 30 minutes edition. There we go. Opening a second screen window, is how we call that. And I'll show you my solutions within the second window. This is RHCSA, and in RHCSA, you want to be in a root cell. That's what I told you in the beginning of this class, and in most cases, of course, that is correct. Do not forget, for containers, it's different. Containers, you don't want to be in a root cell. You want to be in a non-root cell. Now, question number one, install HTTPD and configure it to run on port 82. You will notice that some of the configurations are already as requested. I will proceed as if this is not the case. So dnf install -y HTTPD is the first command you need to run. And then we need to configure it to run on port 82. And that will be through etc httpd conf httpd.conf. Now, before I'm going to really do this, I should mention that on the exam, you will not be asked to configure a service to run on a non-default port. But the reason I'm including this question anyway on this mini sample exam is SC Linux, of course. How are we ever going to test SC Linux? How are we ever going to be able to talk about SC Linux if we can't reconfigure services? So keep that in mind. Now, the trick would be to look for port 80. That's where HTTPD listens by default, and then you change that to listen 82, and then you save your configuration. And next, of course, you are going to do SC Linux. Now, I could imagine that on an assignment like this, you are immediately getting stuck because you don't know where to go. What are you going to do in cases like this? Well, very simple, you leave it alone. In the exam environment, you have like a web page, and in the web page, you can flag every single question with its current status. So you can flag it for revisit. If it needs additional attention, you can flag it as done, and you can leave it unflagged as well. But the first advice I'd like to give you is don't get stuck on questions where you have no clue. Pick the low-hanging fruit first, and that means that you are going to proceed with the next question. The biggest risk is that you approach this exam as if you were IT staff. What does IT staff do? They come across a challenge. They want to finish the challenge. And until it is done, they don't look any further. That's not a very smart way. Now, how are we going to do it? Well, SJ, let's explore. System CTL. No, System CTL. Restart. HTTPD. And jobs for filled, and oh boy, that doesn't look good. Now, how about journal CTL -XEU HTTPD? Is giving me what? Is giving me, oh, there we go, permission denied, could not bind to address 82. Hopefully you know enough when you see that. If you still feel hesitant about it, then I would say switch to permissive mode, try it again. And if in permissive mode it does work, then you have confirmed that it is SC Linux. But hey, now that we know a little bit more about SC Linux, you probably want to go directly to grep EVC var log audit, audit.log. where we can see a message that is telling us that the name bind failure for the HTTPD process to port 82. So what are we going to do about it? Well, there are two different directions. Direction number one, you do know what to do. Direction number two, you don't know what to do. Of course, we do know what to do. We need to use SE managed port and change the port assignment. But in case you don't know, give it a chance and use journal CTL pipe grep SE alert. I warned you for SE alert, and I told you that sometimes it's not very good, but in other cases it can be useful. And if you really have no idea, well, get some inspiration from alert. So let's paste this through less. And what do we see? Plugin bind port suggests. And look at this. Isn't this a beautiful command? It's almost correct. The only thing we miss is HTTP port underscore T. You would have found equally useful information in the man page of SE Managed Port, by the way. HTTP port T, that's what we are going to need. Let's paste it. Change port type to HTTP port T and set it and try it again. Now systemctl restart HTTPD, and as you can see it's instantaneous, and systemctl status HTTPD, and it is active and it is running. So this HTTPD thing is doing all right. And yes, MB, you can find SC alert in varlog messages and also in journal D, in the journal CTL output, is what I should say. Journal CTL output or varlog messages, that is exactly the same. So one down, six more to go. So next we need to create user lorry and set the shell to sbin no login. That should be an easy one, but hey, in case you have no clue, user add minus minus help, and user add minus minus help will show this minus s option. So user add lorry minus s slash sbin slash no login. That will create the user and verify that the shell has been set. Now, if a command is so simple, you also have time to verify it, right? Too often, people make silly mistakes and they don't verify carefully and they overlook the silly mistake. That's not really smart. So let's do a grep lorry on etc pass wd, where we can see that the shell in the last field is set to slash sbin slash no login. Then find all files in the etc directory containing the text strater and write a list of the file names to txt straterfiles.txt. Of course, you can do that using find, and the question is a little bit misleading, and you need to have an eye for that on the exam as well. If a question starts with find all files, they precondition your brain, and you want to use a find utility, don't you? But maybe you just want the grep utility, grep minus L strator on star. That is giving me a list. Too greater than dev null. I don't want to see, that was a typo. I don't want to see any error messages. So I'm redirecting this, and there we go. And we have the list that we need. Using greater than slash txt slash strator files dot txt. Oh, that's so annoying. I don't have the slash txt directory. So you know what I'm going to do? I will use Control A to move my cursor to the start of the command line. And I'm putting mkdir slash txt in front of it, followed by semicolon. That's the easiest way. And there we go. That was number 3. Then we need to create a symbolic link with the name TMP hosts pointing to etc hosts. Yeah, GC, the question really is not clear about that. On the exam, you should expect the question to be more clear. Yeah, should you assume recursively? Maybe I need to rewrite this question to make it clearer, because it's really not fair to leave you in doubt. And this is not something to be seriously considered on the exam. But hey, On the exam, it will be obvious what you need to do, and they will do the wording in such a way that there won't be any doubt about it normally. Okay, we need to create a symbolic link. ln minus s etc hosts tmp hosts. Hopefully that's an easy one. ls minus l on tmp hosts to verify, and yeah, it's a symbolic link to etc hosts. And GC, the parameter in addition to my response, if you want to make it recursive, minus R, that will make it recursive. Number 5, create a group sales. So group add sales. Add a shared group directory data sales, mkdir minus p slash data slash sales. And ensure that all new files in this directory are group owned by the group sales. That is an interesting one. How are you going to make sure that all new files are automatically group owned by the group sales? Well, there's a couple of things that they're not asking, but I would definitely start by using chdrp sales on data sales. Next, I would use chmod g plus w on data sales and ls minus ld on data sales. And what do we need to do next to make sure that all new files in this directory are group owned by the group sales? Well, we need this famous set group ID. So how are you going to do that? Yes, SJ, that's correct. Chmod G plus S on data sales. First, you are going to verify using ls minus ld, where you're looking for the S at the position where you normally find group execute. Next, can you please also go in the directory and touch a new file or whatever? Verify that it is working. And even if I'm doing this as user root, all new files that will be created in this directory are group owned by the group sales at this point. And that's what we wanted. Then create an LVM volume with the size of 50 extents, and if necessary, grow an existing volume group to do so. So we need to start VGS, and I can see VG data has 504 megabytes free. That's cool, and that makes it easy. If it is not that easy, you don't have disk space available, you need to go through the entire range of events. So you start by creating a partition. You set the partition as the LVM partition type. You use PV create to mark it as a PV. You use VG extend to extend VG data with this additional partition. But hey, I don't have to do this, so let me keep it easy. Create an LVM volume with the size of 50 extents. That would be LV create. Of course, it's weird that I'm not asking for a name. Let's just check what is happening if you don't know, if you don't use a name. I will use minus L50. That would by default use extents. And next, I am going to specify the names. So /dev /vg data /dev/vg data. That should be enough, isn't it? And look at that. Logical volume lvol0 was created. It's elegant to specify a name, but if you don't specify a name, you get an automatically assigned name. And that is what we see here, automatically assigned name. I would suggest use LV display after doing so on dev VG data lvol0 to verify that it was correct, that it was created correctly. JS is asking, do you have to add megabytes or gigabytes? Absolutely not. Because the question was to create a logical volume with the size of 50 extents. The current LE, that's for current logical extents, is telling me that the logical volume was 50 extents. You can also double check if you're not completely sure. Then you would use a VG display on the VG data. where you can see that the PE size, which is the physical extent size, is set to 8 megabytes. My logical volume is 400 megabytes. 50 times 8 is 400 megabytes. So in all ways, I'm pretty sure that this is correct. Then question number 7 is an easy one. Set the recommended tune D profile for your system. Well, it's an easy one if you know how to do it, obviously. If you don't know about tune D and stuff, then it is not that easy. So how are we going to do this? Well, tune the ADM. Tab tab, is it helping? Yeah, tab tab is helping. And I'm using recommend to find out what the recommended profile is. Please ignore the message is tune D running. That is an expected error message. Even if it's not very nice, it is normal to get this. Next, you use tune D ADM profile virtual guest, and that will apply the changes and set the profile, and with that you are you are done. And that was the end of this mini sample exam. And with that, folks, 40 minutes remaining. Time for some Q&A. If you have questions, we have time for it. In the meantime, if you have already cloned my Git repository, do a git pull. And if you do a git pull, you will see that it downloads the updated resources.txt. I have worked on the resources.txt while you were working on this mini sample exam, and I have created a list of everything that is relevant in the context of this course. First 2 items are for the recorded video course as well as the book. I hope you have already found it, but you never know. Second and third, the RHCSA Challenge Labs and the RHCSA Labs. That is a simulated hands-on environment. And last, I have listed all the relevant live courses. Now, about these live courses, let me vim on resources so that I can tell you which ones are not coming soon. First, Linux Certification Labs is a new course, not scheduled anytime soon. Containers in 4 hours next week, Linux security next week, Linux troubleshooting next week. Using Red Hat Hybrid Cloud Console, rescheduled in February, so you need to be patient. Linux performance, Linux under the hood next week as well. So make sure you check these out, and I'd love to see you there next week or some other time. I'm going to work on my pastebin, and while I work on the pastebin, can you please send questions that you are posting? I'm aware that some questions are already waiting, but I'm first going to create the pastebin. You also know that you will get access to a recording of this class. The recordings typically are pretty fast nowadays, so that shouldn't take too long. In the pastebin, I will start with the root user commands, followed by the user student commands. Oh, that's 155. Mainly about containers. And I'll also use the user Linda commands. Not very many, but we had a couple of them. All right, I'm almost ready to send you the pastebin. Just clicking create new paste, copying and pasting. Oh, there we go. So your questions. Let me scroll up a little bit. MB is asking about the challenge lab. The challenge labs were created for RHEL 8. They still do pretty well on RHEL 9. Uh, right. PM is asking if I can provide any technical procedural tips regarding the exam that not breach the NDA, please, like time management. Yeah, regarding time management, pick the low hanging fruit first. Mark all questions that you cannot answer immediately as a revisit. Start with the low hanging fruit, then you work on the questions where you think you can do it, and keep the questions where you have no clue to the last. To verify your sequence, well, to verify your solutions, I've given you some impression on how to do it. It really depends on what you needed to do, but definitely you need to check out what you have done. Is there any sequence? Well, read the questions. It doesn't hurt if you scroll through the questions, have a quick look at all of them before you start. Now, I also need to be honest, I never do that. I just pick the questions in order. That never took me into any trouble, but I would definitely recommend to read the questions because you never know if there is anything that is depending. The pass fail score normally, formally comes within 3 business days. I have seen it coming normally same day within a couple of hours, but on occasion it can take much longer. Should be there within 3 business days. Right. Any more questions? MA is asking, what is the best way to prepare for the exam? Have a look at the PDF of the book that is available on this site and use this PDF. It has sample exams. Make the sample exams. I do not have any solutions for the sample exams. You are supposed to be able to do that for yourself because that's what you need to do on the exam as well. I mean, if you need me to verify your sample exam, to me that means that you're not ready for the exam. If you are ready for the exam, you do the sample exam and you can verify. And if you are not at that level yet, consider more studying. Some people visit this class more than once. I have people visiting 3, 4 times because if today, in the last 3 days, everything was new, you will learn so much new things. You will get so much new insight if you attend it again. So feel free to join again. And yes, JS, I know the containers today. I can imagine that you want to visit that again. Do so. Also, containers in 4 hours. I need you to be prepared. I won't do that entire story about Podman unshare in containers in 4 hours. Containers in 4 hours emphasizes different topics, but I need to teach that class so that people who are only interested in Docker are also getting out of it what they need. RM, I'm so happy that you love this course and write anything else. JJ, oh boy, you have your exam tomorrow. Well, good luck on all of that. And B is asking, there will be more RHEL 9 RHCSA courses, approximately every 10 weeks. Now, the sad thing is that this year I had much more time on the platform than what I will have next year. Normally, I would say every 2 months. That might be every 3 months next year with limited time availability, but for sure, this class will run again. And may I give you one more suggestion? I cannot tell you anything about it right here, but look for me on LinkedIn, connect with me on LinkedIn. There will be an announcement pretty soon. I hope within a week or so. There will be an announcement pretty soon about a service that you might like. Can't tell you anything about it on this platform, but do connect and you'll hear about it. And if you really can't wait, drop me an email. Here is my email address. And JS is asking, what new thing am I learning? Well, JS, honestly, at this point, I'm not learning anything new. I'm producing new stuff. There are so many courses that need an update and that I want to provide information about. So I'm not deepening my knowledge. And let's face it, folks, I'm trying to be an expert in Linux, in containers and Kubernetes and in Ansible. And at some point, it is enough. I need my time to keep my skills up to date. Uh, Still on my wish list, Python. I would love to be an awesome Python programmer. But yeah, that's still on my wish list and probably will be there for a long time. FS, my OpenStack courses was one of the first OpenStack courses on the market. Unfortunately, slightly off topic, but in the beginning, OpenStack had perfect learning environments like Packstack. Nowadays, that is no longer the case. And for that reason, sadly, since 2017, I have not done any update on OpenStack. And it is unlikely to see updates on OpenStack uh, pretty soon. Yeah, Python in 4 hours. I'd love to do that, but I know there's fierce competition about Python. You know what frustrates me about Python? Another off-topic thing. Everybody seems to think that I need 4 weeks to learn Python. That's not 4 weeks. I want to be able to learn it in 4 hours. And folks, with that, I think we are out of real questions. So I am going to call it a day. Uh, FS, one more thing. You're asking about SE Linux. Oh boy, I forgot one thing in my course resources. I'm so happy that you are mentioning it. If you need to learn more about SE Linux, I have a recorded video course about SE Linux and I am sending you the link right now. I wanted to include all the cool stuff about SE Linux. So you need to deepen your SE Linux knowledge, go here. Regarding SE Linux, if you thought that was a difficult topic, come back next week. Next week in Linux security, I'm covering SE Linux as well. And you will notice when you come back next week, you hear about it next week, you will have not such a hard time understanding it. You will actually understand because it's the second time that you will attend and you already know about all of these concepts. And with that, dear everybody, the sad moment is there. It's time to say goodbye. So thank you very much for joining me throughout this course, and I hope to see you soon. Take care, everybody. Thanks again, and bye bye.
All right. Thanks a bunch, Sander. All right, everyone. We'll see you back soon. Have a great rest of your day. Take care, Sander. See you soon, too.
Thanks, Pat.